Hey everybody, in this lesson what we're going to be doing is we're going to be talking about polygons and then we're going to focus quite a bit on quadrilaterals in here as well. So the first thing is that we need to know the definition of a polygon, and so that's going to be a closed figure with at least 3 straight sides. So up here at the top I have included examples of polygons, and then down at the bottom these are ones that are not polygons. The first one is because the corners are rounded, so not all of the sides are going to be straight, and actually there's really just one continuous side, I suppose. This one here, it's closed, but we have a piece that comes into the shape, so therefore that cannot be a polygon. If we were able to get rid of this part inside, if we got rid of that, then it would be a polygon, but that part makes it that it is not. And then our last one here, it's not closed. We're missing a piece somewhere there, so that one cannot be a polygon. Then the next thing is that we need to name parts of our polygons. So we know that this is going to be called a side, and then all of the corners are going to be a vertex. So the shape up at the top has 4 vertices. When we spell the plural of that, that's how we spell it, vertices. And then the next part down here at the bottom, a diagonal is going to be a line segment that connects 2 non-adjacent vertices, so not next to each other. So for example, these two are next to each other, so we cannot draw a diagonal to connect those two, but these two are non-adjacent, and therefore I can draw a line that connects them. I think I'm going to do like a light gray color. So those two can connect to make a diagonal. I could also go between these two, and then those are the only, looks like those are the only ones that I can do from that part right there. Now there are many diagonals, and something that's kind of interesting as I draw in some of the others here as well is that not all diagonals have to stay inside of a shape. So an example is going to be connecting these two right here. This is a diagonal that went outside of the shape. Now it doesn't always happen like that, but it is possible for a diagonal to go outside. I don't think I have drawn every possible diagonal in this picture, but we do have most of them. Okay, so we also need to know the difference between concave and convex. So convex over here, that's going to be when all diagonals must remain inside of the polygon. So I can demonstrate with this here. There's going to be only 2 diagonals. There's both of them. Oh, that should have connected. There's 2 of them. And then another fact about the diagonal, or another fact about a convex polygon, you'll notice that all vertices are pointing outwards. So all vertices point to the outside. Meanwhile, for the concave shape, at least one diagonal goes outside, and I can see that the diagonal right there is the one that would have gone outside the shape. Meanwhile, for this as well, at least one vertex points towards the inside. And in fact, this one here is the one that's pointing in, whereas all the other vertices were pointing out. By the way, for everything that we're going to talk about then beyond this point, not just for this video, but actually for the remainder of the class, we're usually going to focus on just convex polygons. Now we have to get into the names. So a lot of these names over here you already know based off of their side lengths. So you should already know a triangle. You should know, now for 4, a lot of you probably would say square, a lot of you would probably say rectangle, but you have to realize that does not include the rhombus. It does not include the parallelogram. Sorry, it doesn't include the trapezoid. So we're going to summarize that. We're naming these based off of how many sides they have. So that's the quadrilateral. Then for 5, you know that is a pentagon. Funny story, at another school that I taught at, for some reason, all the students would always tell me that a 5-sided shape was a polygon. And I would say, well, yeah, but that's not what I'm looking for. I want you to be calling it a pentagon. And I'm not entirely sure why. For some reason, they just didn't learn the name pentagon, I guess. For 6 sides, you should know that is a hexagon. For 8, you should know that is an octagon. And those are really the only ones that I feel you absolutely should know already. As for the others then, the 7-sided shape, there's actually 2 names that we have for them. We do have a septagon, or I have also seen it called a heptagon. Either of those are acceptable for a 7-sided shape. Then for 9, that is going to be called a nonagon. And then for 10, we have a decagon. Now, this last one then might be a little confusing. It says n. Now, n represents any number. So it could be a 12, it could be a 15, it could be a 1,000. It doesn't matter. It could be any number. When we have more than 10 sides, we typically then just call it an n-gon. And I do have this bit down here at the bottom. Some shapes with more than 11 sides do actually have a special name. So for example, a 12-sided shape is called a dodecagon, but it is still acceptable to call a dodecagon a 12-gon. Now, I've had some people in the past that thought it would be funny, and for example, they tried telling me a triangle is a 3-gon. I just want you to know I'm not going to accept that. You try to call a pentagon a 5-gon, I'm not going to accept that. When you use n-gon, I want you to know that it must be n is greater than or equal to 11. All right. So now we're going to get into some more specific definitions of some of the shapes that we have discussed. So the first one is going to be a quadrilateral, and that is a polygon with 4 sides. So first thing is that we need to know its adjacent sides. So AB and BC are going to be adjacent. Then we have BC and DC. And then we have DC, AD. And then finally we have AD and AB. Then for the opposite sides that are on opposite ends of the quadrilateral. So we have AB and DC. And then we also are going to have AD and BC. There we go. Okay. Next one, adjacent angles. So angles that are next to each other, we're going to have angle A and angle B. Then to angle B, angle C is also adjacent. To angle C, angle D is also adjacent. And then finally, angle A and angle D are adjacent. As for our opposite angles, ones that are on opposite sides of the shape, there is angle A and angle C. And then the other pair that we have are going to be the other two that we didn't name, angle B and angle D. And then finally, the name of the quadrilateral. I'm not saying that we're supposed to name it as what type of shape. I'm not looking for trapezoid. I'm not looking for square, rectangle. We're supposed to name it using the 4 letters. And all we have to do is we just need to make sure that we name it in order. So A, B, C, D is one way to name the quadrilateral. Now you don't need to go in alphabetical order if you don't want to. It just has to go either in one direction or it has to go in the other. And you don't need to start at A either. If you wanted, you could start at D. And you could have said D, C, B, A is acceptable. If you wanted, you could have started at B. You could have said B, C, D, A. As long as the letters are going in order around the shape, that's all you need to do to name it. So, and there's more options there. All right, so now we have the square. And you know already that it's going to be 4 congruent sides, and there's also going to be 4 right angles. So all of those will be true. So we know that we are supposed to find x and y then in this square. We already know that the side lengths are 15. So because of that, this 3y has to be 15 as well, and the x plus 2y has to be 15. We have a problem though. We are not able to solve that one yet because there's 2 variables. Instead, what we have to do is we have to focus on the side that has only one variable, only one unknown, and that is 3y and 15. So we're going to start by just writing 3y equals 15. We know that we have to divide by 3 to solve this, and y is equal to 5. Now that we have that, we can go ahead and we can change this side down here into x plus 2 times 5, or x plus 10. And we also know that x plus 10 is supposed to be 15. So then we just need to subtract 10 from both sides, and x is also 5. For a rectangle, 2 pairs of congruent sides and 4 right angles. So we have these 2 angles here. Both of them need to be right. So we know that they're both going to be 90 degrees. Kind of like the previous example, this one cannot be solved yet because we have 2 variables. There's not enough information in order to solve that. So instead, let's focus on this side here. We have 90 and 2y plus 10. So we can set those equal. And then we know that we're supposed to subtract 10 from both sides. We get 2y equals 80. And then we have to divide both of these by 2. And y is going to be 40. Now that we have 40, we can rewrite this angle here as 40 plus x. And then, in order to solve for x, we will set 40 plus x equal to 90, and we can see that x will have to be 50 degrees. All right, now our next shape is the parallelogram. So we have 2 sets of parallel sides. That's what these markings are. Those 2 sides are parallel. These 2 sides are parallel. Another thing that people often forget about a parallelogram is that its opposite angles are congruent. And I think that should be kind of easy to see because right now I drew in 2 of the acute angles. And now these other 2 that I marked with 2 curved lines are going to be obtuse angles, and those are also the same. And one other thing, I'm going to actually change the color on here so it's a little more obvious. Adjacent angles in a parallelogram are always supplementary. They always add to 180. So in this picture, if you take one green angle and you take one pink angle and you add them together, that is always going to be 180. Okay, I want you to try this question then on your own. So you are told that this shape is indeed a parallelogram. I want you to solve for both x and for y. Pause the video here, and then when you are done, I will demonstrate how to find the answers. All right, everybody. So we know two things about parallelograms here. The first one, maybe I should actually draw it like this, kind of like what I just did in the last picture. One green and one pink angle are going to always add together to be 180 degrees. However, we should not add these because then we have both x and y. We're not able to solve that. We can't add those together. We have x and y. We can't solve that. So instead, I'm going to focus on just these two green angles here. And from the previous slide, we knew that opposite angles in a parallelogram must be congruent to each other. Therefore, I can set these equal. 2y plus 10 is equal to 3y minus 45. Now we need to solve by getting the like terms on the same side. So I'm going to subtract 2y from both sides. Those cancel. We're left with 10 equals y minus 45. We add 45 to both sides. And we get 55 is equal to y. Now that we know that 55 is equal to y, we can put that in for either of these angles, and I'm thinking that the top one here looks a little easier. So I'm going to write 2 times 55 plus 10. And if we keep simplifying that, that becomes 110 plus 10. And therefore, that angle is 120 degrees. So let's go ahead. I'm going to move that down so it's a little easier for us to see. Okay, now these two angles must add together to be 180. So let's take 120 plus 3x equals 180 degrees. I'm going to subtract 120 from both sides, and we get 3x equals 60. Then I'm going to divide both sides by 3, and x has to be 20. All right, so two more quadrilaterals for us. The rhombus. So a rhombus is going to have 4 congruent sides. That's what these markings are right here. And then something that is also true about a rhombus is that its opposite angles are going to be congruent. So I've got the 2 green on the top and bottom. Those will be congruent, and then the 2 purple are going to be congruent as well. And then below, what we have is the trapezoid. And a trapezoid has one set of parallel sides. So I've marked in the ones that are going to be parallel there. One thing I forgot to mention about the rhombus too, you'll notice that it says 4 congruent sides. You already know a square has 4 congruent sides. A square is a type of rhombus. However, a rhombus is not going to be a square. Okay, for this question then, you are told that the angles of a quadrilateral are going to be 90, x, 2x, and 3x, and you are supposed to find x. I'll give you a hint. All of the angles of a quadrilateral add up to be 360 degrees. So pause the video, try to solve this, and then when you are done, you can start up the video again, and I will show you how to answer this. Okay, so if we have 4 angles of a quadrilateral, I'm just going to draw something. I have no idea what it actually looks like. So here we go. Obviously, these are not actually correct, but that's not the point. We know then that we can just add all of these together and set it equal to 360 degrees to see what x is. So we got x plus 2x plus 3x plus 90 equals 360. When we simplify, we've got to combine our like terms. Don't forget that is a 1x there. So we are going to have 1 plus 2 is 3, plus another 3 makes 6. 6x plus 90 equals 360. Subtract 90 from both sides to get 6x is equal to 270. And then we have to divide both sides by 6. And let's see, I know that 6 can go into 244 times. 6 goes in there 40 times. But then we need another 30, and I know 6 can go into 35 times. So the answer for this is that x equals 45. Alright, that is everything. So, as usual, go to Sabas Digital Platform then to see which questions you are required to complete and which ones that are optional. Thanks for listening.